All right. Okay, so it's good to see everybody. We're going to do a couple of things today before we get to SEL. Okay, so first up, you got the homework for the imaginary numbers. Now, we should be on track to go ahead and finish that Monday. We'll take a little bit of time, but the assignment will be due on Wednesday of next week. So that gives you plenty of time through the weekend, even early next week, to go ahead and get that taken care of. After we go ahead and talk about imaginary numbers, we'll talk about the quadratic formula homework. I do want to go over that little exit ticket from yesterday. Okay, going into next week, let me show this. Okay, remember on Monday, we're going to go ahead and take most of the period to review quadratic equations and the different methods we have to go ahead and solve those. On Tuesday, you're going to want to bring your charged Chromebook to class because that next quiz is a CFA. So that's coming up on Tuesday. And then for the rest of the time, we're going to be looking at complex operations. So I'm hoping to have everything wrapped up before the end of next week. That way we go to Thanksgiving break, don't have anything to worry about. But remember, next week, no morning tutorials. Okay, I will be in the dining hall if anybody needs me, but I will have after-school tutorials on Tuesday and Wednesday of next week. Okay, questions? Okay. Well, what do you say we go ahead and get started with the exit ticket from yesterday? Okay. All right. So let's go ahead and run through this. So we've got three methods to go ahead and solve these: factoring, completing the square, and then the quadratic formula. And you are free to use whichever you like. There are some that I would think are going to be better than others. The only one that won't work 100% of the time is factoring. Okay, now on number 4, I did tell you that that's the one that's factorable. Okay, so if we're going to factor it, we want everything on one side. So 2x squared plus 8x plus 6 is equal to 0. Okay. So we have it set equal to 0, GCF, 2. So if I pull out a 2, that's going to leave me x squared plus 4x plus 3 is equal to 0. Now, no variable came out with the 2, so we're going to ignore that. What two numbers multiply to give me 3, but had to give me 4? So it's got to be x plus 1 times x plus 3. Okay. And then what do I do with each of these groups? We set them equal to 0. So if x plus 1 equals 0, we have x equals negative 1. If x plus 3 equals 0, we have x equals negative 3. Okay. So there we go. There was the first one. Okay. I would say an overwhelming majority of folks got that right, so fantastic. It was the number 5 that some people had a little bit of trouble with. So for this one, because we were just recently talking about quadratic formula, and that's the assignment that's due today, I'm going to go ahead and do this with the formula. Okay, so x squared minus 16x plus 57 equals 25. Now the quadratic formula, just like factoring, it has to equal 0. So I'm going to go ahead and subtract the 25 over. And what is that going to give me? Okay. I'm looking at 32. Okay, so this is going to be, I'll do it down here, x squared minus 16x. So 57 minus 25 is going to be a 32, and that's equal to 0. Go ahead and erase that. Okay. Once everything is on the same side, this is when you identify A, B, and C. So A is 1, B is a negative 16, and we see that C is now A, if it let me write this, is a 32. Okay. Now, what's that first expression that we find if we're going to use quadratic formula? B squared, was it? Minus 4AC. So B squared minus 4AC. What do we call that? That's the discriminant. So we're going to say a negative 16 squared minus 4 times A is 1 and C is 32. Okay. So I'm looking for a negative 16 squared. 256. Okay. Remember, I did provide you that new list yesterday, but even if you're not sure, you could do some multiplication over to the side. 16 times 16, we're good to go. Okay. Now, we know we're going to be subtracting something. So I need a 4 times 1 times a 32. So minus 128. Okay. So what's a 256 minus 128? It is 128. Okay. Now, because that turned out to be a positive number, that tells me there's two real solutions. Okay, so let's come on back to the formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac, and this is all divided by 2a. Okay, so let's plug in. Opposite of b. Okay, so that's a positive 16. Plus or minus, well, that discriminant, we just found that to be 128. Okay, that's a major portion of the quadratic formula already taken care of. And then we're going to divide it by 2 times a, so that would be 2. Okay. Now, the only thing left in our way is simplifying that square root right there. So think about all of your perfect squares, 1, 4, 9, 16, 25, etc. What's the largest one that divides 128 evenly? $64. There we go. So 128, I can rewrite this as the square root of 64 times what? Times 2. So we can take the square root of 64. This is going to give me 16 plus or minus 8, but 2 has to stay inside, and this is divided by 2. So that's why this one's not factorable. We have a radical solution. Okay, now the last thing was to go ahead and break those apart. So I'm going to say 16 over 2 plus or minus 8 root 2 over 2. So that's why we're getting 8 plus or minus 4 square root of 2. Here we go. All right, question. Okay. So all in all, you folks did really good on that exit ticket yesterday. I don't know if you saw, but your class average on that was a 90.9. So that is fantastic. That is fantastic. And remember, we're going to review more on Monday before the quiz. So I think you're going to be just fine. I'm confident. Okay. So let me see here. Let's go back. So this is the quadratic formula. So remember, there were certain problems that we said not to worry about. We are currently learning about imaginary, okay, but were there any problems from the quadratic formula assignment we would like to take a look at? Okay. Did we just want to do another one for practice? Okay. 1, 2, or something later? 1. Perfect. Okay. So x squared plus 12x minus 8, it's already equal to 0. Okay. What's A? A is 1, B, 12, and C, negative 8. Okay, so we're going to find that discriminant first, b squared minus 4ac. So that would be 12 squared minus 4 times a times c. All right, well, a 12 squared, 100, bless you, 44. We've got a negative times a negative, so that's going to be a plus, but 4 times 1 times 8. 32. Okay. So I'm looking for a 144 plus 32. That is a 176. Again, because it's positive, that means I've got two real solutions. Okay. So now to the formula. X equals the opposite of b plus or minus the square root. Okay. Over b squared minus 4ac, all divided by 2a. All right, so what's the opposite of b? negative 12, plus or minus. We found the discriminant to be 176. And what are we going to divide that by? 2. All right. So again, we have a non-perfect square that we just need to go ahead and break down. Now, there is another way to do this. If you don't want to think about it, if it's kind of difficult, especially with a larger number such as this, trying to figure out which perfect square evenly divides it, you can create a tree. You can just start breaking it down into a product of its prime numbers. Okay? Like, for example, this is definitely an even number, so what is half of 176? Okay, 80. 83. Okay, does everybody agree with that? No, we're a little off. 88. Okay, so I'm going to go ahead and say 2 times 88. Okay, so I'm just trying to show you an alternate method in case this is something that you struggle with. I want you to be able to simplify radicals like the rest of everybody. Okay, so we're going to have to do another layer because 88 is not prime, so I'm going to bring down this 2, and we don't have to continue with 2. As long as we can break it apart into a product, that's what we're interested in. Okay. So let's just stick with 2. So 2 times what is 88? 44. Okay. So I'm going to bring down this 2, bring down that 2. How would you like me to break apart the 44? 2 times what? 22. Okay. We got to add one more level, so I'm going to bring down all these 2's here. How am I breaking apart 22? 2 times 11. Okay. So anybody ever seen one of these trees before? I would imagine surely in Algebra 1 that showed you folks that. But this is just another way if you're kind of struggling. Remember, we're looking for a square root. That's a number you multiply against itself, right? So when you make the tree, you can pull a number out if you have 2 of the same value. So see, I can pull out a 2 because I have 2 2's. But I've got another pair of 2's. I can pull out another 2. So I'm going to multiply those. I've only got the 111, so it has to go back inside. Okay. So that means that square root of 176 is going to become 4 square root of 11. So that means the largest perfect square that divides it would have been 16. Okay. Just another way to take a look at that. So that's going to be a negative 12 plus or minus. We now have 4 square root of 11 over 2. Okay, let me go ahead and get this out of the way. All right. And the last step is just to separate it so that we can simplify. So this is going to be a negative 12 over 2 plus or minus 4 root 11 over 2. So what am I looking at for my final answer? Negative 6 plus or minus 2 square root of 11. There you go. So unfortunately, this one here, if I tried to factor it, it is not going to work. Okay. You know, really, and this is the worst answer I could probably possibly give, but it really just comes down to experience. The more comfortable you feel with factoring, you're going to be able to see, or even if you start the process, you're going to be able to see pretty quickly that nothing's going to come from it, so you want to switch to another strategy. All right. Was there anything else on the quadratic formula we wanted to take a look at? All right. Well, is there anybody ready to turn that in? That's okay. All right. The only other thing I want to do, we're going to get a little further with the imaginary numbers, and then we're going to call it a day. Okay. So go ahead and pull out. Let me go ahead and set this back up for that other class. Let me go ahead and make sure to erase this. Okay, so let's go to imaginary. Okay, so we had an introduction to imaginary numbers yesterday, which basically means we are learning now how to simplify square roots of a negative number. Okay, so this is our definition. I equals the square root of -1. So we simplify the square root like normal, but we're kind of just pushing that negative over to the side, and we're calling it this new variable. Okay, so I've got a couple of examples for us to start with. Let's say I gave you the square root of a -121. Okay, so that one's a perfect square. Anybody tell me what that is? 11i. Remember, what we're doing here is we're going to go ahead and take the -1 and we're going to separate it from everything else. So the square root of 121, yeah, that's 11. But here's our definition. The square root of -1, that is I. Okay. Let's try another one. What about if I gave you the square root of a -15? Well, the first thing I'm going to do is separate that negative from the 15. Now, 15 isn't a perfect square, but can I simplify it? Okay. Well, let's see. Give me two numbers besides 1 and 15 that'll multiply to give me that. Okay, 3 and 5. Well, based on what we were just discussing, neither one of those are perfect squares, so that means the 15 has to stay the way it is. The only thing I can take care of is the square root of -1, which is I. So this would just be I square root of 15. Okay. Now let's say you did have a value that you could simplify. Like what about the square root of a -40? Okay, so I'm going to break this apart. So here's the -1. So what's the largest perfect square that would evenly divide 40? Okay, what's that? Okay, 4. In fact, 4 times what? 4 times 10. So let's see here. The square root of 4, that's 2. What's the square root of -1? I. And then 10 has to become your new radicand. In fact, if anybody would like, I can create a tree real quick out of 40 to show you that we are going to get 2 root 10. Does anybody want me to do that? Okay, let's do it. So let's do the 40. Okay, and it doesn't even matter. I don't have to use the same numbers. Let's use something else. Let's say 2 times 20. Okay, so now I've got to add another level. Give me two numbers that multiply to give me 20. Okay, 4 times 5. Okay, so I got to bring down this 2, this 4. Let's split it up into 2 times 2, and now we got the 5. Okay, let's see. I've got a pair of 2's that allows me to pull out a 2, but I've only got 1, 2, 1, 5. I can't pull out anything else, so they've got to multiply back together and stay inside. Yeah, don't get me wrong. We would prefer that you're able to think about these perfect squares and simplify those, but if you're having a hard time, this can help you out. Okay, you will get better. Okay, questions? Okay. Well, we're going to go ahead and start skipping around a little bit. Go ahead and flip to the back. Let's look at number 12. Okay. It says a -2/3 x squared minus 1 equals 17. Okay. So what we want to do is just isolate the x. Okay. Walk me through. What would you do first? We can either work with something now or we can go ahead and get rid of it. What am I referring to? Okay, the fraction. Okay, I'd probably go ahead and multiply through by that 3. So that's going to give me a -2x squared minus what? Minus 3 equals 3 times 17? 51. Okay. See, now it looks a lot nicer. Okay. So let's add the 3. So a -2x squared is equal to 54 when I add the 3. Okay, everybody's good? Okay. And then divide through by -2. So x squared is equal to 54 divided by -2. -27. Now we want x, so we're going to go ahead and take the square root. Okay, so don't say it out loud. Take a few seconds. Think about what we've discussed. Simplify this radical for me. Everybody ready? Okay. We should be getting 3i square root of 3, but what am I forgetting? Remember, we solved an equation with an even root, so we're going to put that plus minus in front. Okay. Does anybody want me to talk about how we got the 3i root 3? Okay. How are we doing? Feeling good? Okay. Unless anybody has any other questions, that's all I have for today. Unless you want to make SEL, math SEL. You sure? I thought I heard someone say yeah. Okay. All right. So let's go ahead and put that stuff up. Let me turn this off.